How long is the coastline of the United States? You might think the answer to that question is as simple as typing it into Google and seeing what comes up or measuring it all out yourself. But it's actually a very strangely complicated question that might be impossible for anyone to really answer no. When you type the question into Google, you'll end up with 3 completely different answers from 3 separate trustworthy sources. The Congressional Research Institute cites that the length is 29,093 miles, while the CIA cites a different number at 19,924 miles, while the National Oceanic and Atmospheric Administration, or NOAA, cites a way higher number at 95,471 miles. And the discrepancy between all 3 of these different organizations' answers isn't unique to just the coastline of the United States. Consider the following question. Which country has the longest coastline in the world? Most sources will agree that the answer to that is Canada, which might not be too surprising because Canada is a geographically huge country and the 2nd largest in the world, where its sheer length of coastline can be clearly seen on a map. But according to the CIA's World Factbook, the answer for the country with the world's 2nd longest coastline is a lot more interesting and less expected: Norway. It's potentially unexpected because Norway isn't really a huge country, and at first glance, it doesn't really look like Norway's coastline is particularly long either. But the thing about Norway is that the closer and closer you zoom in on the Norwegian coast, the more complicated it appears to become. The coast is dominated by jagged fjords that zigzag around in every direction, and then there's all this seemingly endless amount of islands to consider as well. It turns out that Norway actually has the 2nd highest number of islands of any country in the world. There's more than 239,000 of them. In fact, the top 3 countries in the world by number of islands were all pretty surprising for me to find out, because they're all just next to each other right here in Scandinavia: Sweden, Norway, and Finland. These 3 countries alone possess more than 685,000 different islands between them, which is rather astonishing because that's more than 3 times all of the other islands everywhere else in the world combined. It's just that most of the Scandinavian islands are all really tiny and uninhabited. Like, just look at all these little islands around the coast just outside of Stockholm. It'd take you days to count all of these up. So, when measuring the coastlines of each of these countries, the lengths of all these hundreds of thousands of islands must be individually calculated and added to the sum of the country's mainland coastline. And since Norway's mainland coastline is also super jagged pretty much everywhere, and there's hundreds of thousands of islands, it's not that hard to understand how the CIA came to the conclusion that Norway's is the 2nd longest coastline in the world. Their final calculation came out to 51,748 miles for the total length of the Norwegian coast, which is more than 2.5 times the length of the entire United States coastline that they also came up with. But also only about half the length of the United States coastline that NOAA came up with separately. Essentially, everybody you ask how long a certain coastline is will always give you a different answer. And this phenomenon is known as the coastline paradox. It's also rather easy to see how this can end up happening when you try and measure the coast of a country yourself. Let's take the United Kingdom as a rather straightforward example. The UK is an irregular shape with many different islands, bays, and peninsulas, and no matter how close you continue to zoom in on a place like the west coast of Scotland, the coastline only gets more and more detailed down to the point where you reach the beach itself and the individual grains of sand that make it up. The hardest part about measuring any country's coastline is therefore deciding where to even start. And if you want to be completely accurate with your final number, you're gonna have to closely analyze every single piece of the coastline with something like an electron microscope. And even then, it still might not even be enough. Since that would probably take an infinite amount of time, it's far more straightforward to simply estimate the total length of the coast instead. And the easiest way to do that is by taking a map and placing many equally sized segments or rulers around the country's perimeter, and then adding up the lengths of those segments. So let's use a ruler that's 200 kilometers long. We place several of these 200-kilometer long rulers around the coast of Britain until we surround the island with 12 of them, which, when added all together, equals an estimated length of 2,400 kilometers. Alright, but then let's replace the size of our rulers with one that's only half the size, at 100 kilometers long. We do the same thing with these smaller rulers and now find that it takes us 28 of them to surround the coast, which when added up gives us a new total estimated length of 2,800 kilometers. 400 more than we had during the initial measurement. And then if we have the size of the ruler again to 50 kilometers, it'll take us 68 of them to surround the coast, and adding them all up gives us another estimated length of 3,400 kilometers, which is now 600 kilometers longer than we had during the initial measurement when we were using a larger ruler that was 4 times longer. This is the coastline paradox in action. Each time you use a smaller ruler to measure the length of the country's coastline, the answer becomes increasingly larger to the point where eventually you could be using ruler sizes down to the atomic level, and the answer would begin approaching infinity. And this means that the more complex an area's coastline is, the more open its length and span is to personal interpretation, which has had fascinating implications on global geopolitics throughout the ages. One of the greatest historic examples of this mathematical principle causing diplomatic headaches before it was well understood was back during the late 19th century dispute between the United States and the United Kingdom on where the border between them across Alaska and Canada should actually be set. You see, everybody back then had a different idea on where this border in what is today the Alaskan Panhandle should actually be placed. The United States insisted that it was here, while Canada and the UK government insisted it was here, while the British Columbia government further insisted that it was actually here. And much of the differing claims here stemmed from the different ways that every party was measuring the coastline. 40 years before the Americans purchased Alaska, the territory had belonged to the Russians, and they signed an agreement with the UK that partially defined the border here with a highly ambiguous phrase that read, "a line parallel to the winding of the coast." Of course, the coast in the Alaskan Panhandle region looks pretty much just like the coast of western Norway, and it's covered in jagged fjords and scattered islands, meaning that the extent of how much the coast winds is sort of open to your own interpretation in the way you measure it, which ultimately meant that the border could also be pretty open to interpretation. When measuring out the border that was parallel to the winding of the coast, everybody involved used a different way to measure how much the coast winded that happened to benefit their own geopolitical claims. And thus everybody came up with wildly different claims on where the border should actually be placed. After Alaska's border was firmly set by arbitration in 1903, and after the territory became a state half a century later in 1959, it easily became the US state with the longest coastline by most measurements, and that's not really a surprise, because Alaska is by far the biggest state in the country by area. But of course, the issue of how to accurately measure Alaska's jagged coastline and many islands has remained a problem in cartography through to the present day. Using 2 totally different methods, the Congressional Research Service published a report for the US Congress that measured the Alaskan coastline at 10,960 kilometers, while NOAA measured it separately at nearly 5 times longer than that at 54,563 kilometers, which does seem a little absurd because that's longer than the entire circumference of the Earth. Regardless of how they came to these wildly different conclusions, both the CRS and NOAA agree that Alaska has the longest coastline of the US states, and they each agree that Florida has the second longest coastline. But fascinatingly, they both disagree significantly from then on for the rest of the states' order, because of their different, yet still equally valid methods of measurement. The CRS believes that California and Hawaii possess the third and fourth longest coastlines of the states, which kinda makes sense because California has a long coastline and Hawaii is a bunch of islands. But NOAA conversely insists that the order after Florida is actually Louisiana and Maine for the third and fourth longest coastlines, which seems odd because when looking at a big map, the Louisiana and Maine coasts each appear much smaller than California. But when you zoom in much closer to the California coast and scroll across it, you'll notice how smooth of a curve it is almost continuously from the south to the north. Conversely, when you zoom in more closely on either the Louisiana or Maine coasts, you can quickly see how insanely jagged and fragmented both of them are pretty much everywhere. And when using smaller units of measurement, like I assume NOAA was using, it's not that hard to see how they came up with the Louisiana coast being more than twice as long as the California coast. And how when using longer units of measurements, like I assume the CRS used, they came up with the opposite result that California's coast is roughly twice as long as Louisiana's. The fascinating thing though is that both of those answers are technically true, and it's simply just up to your own perspective and opinion on whether or not California or Louisiana have the longer coastline. Saying one is longer than the other is not a definitive fact and is purely subjective. This concept of the coastline paradox was first noticed and written about more than 70 years ago in 1951 by a cartographer named Lewis Richardson. He had been studying whether or not the length of borders between countries had any effect on their likelihood to go to war, and during his research he noticed a peculiarity between the border of Spain and Portugal. This is the longest uninterrupted border in the modern European Union, and it is the second oldest border anywhere in the world, having been continuously fixed in place for well over 700 years now, ever since 1297. There has been a very long time for each side of that border to understand its length, and nonetheless, Richardson noticed that the Portuguese and Spanish maintained different official lengths for it. The Portuguese felt it was 1,214 kilometers long, while the Spanish felt it was shorter at just 987 kilometers. This was, of course, simply because the Spanish were using a longer ruler to measure the border than the Portuguese were using, an effect that was later dubbed the Richardson effect. The sum of the segments used to measure a curved line, like a border or a coastline, is inversely proportional to the common length of those segments. In other words, meaning the shorter the segments used to measure, the longer the measurement of the curved line becomes, and the closer you get to the curved line's true length. Now, this method of measuring mostly works fine for smooth curves like the coast of California or the coast of Africa, but it starts breaking down when you attempt to measure jagged coastlines like Norway, Scotland, Alaska, or Louisiana. The closer you look at these kinds of coasts, the more rough edges are revealed. So when you use smaller and smaller rulers, the length of the coast doesn't ever converge toward any fixed answer that everyone can agree upon. It just keeps getting longer and longer as you approach infinity, and so an answer has to be given before you get to that point. This concept was even better explained a decade later in the 1960s by the works of the brilliant mathematician Benoit Mandelbrot, who developed the concept of fractals in geometry. In his 1967 paper titled "How Long is the Coast of Britain?", Mandelbrot explains the concept of fractals applied to measuring the coast of Britain. One of the main properties in geometric fractals is their self-similarity, meaning that no matter how closely you continue to focus on them, the same general shape continues to appear throughout. Jagged coastlines in particular, like the west coast of Scotland, essentially act like fractals because no matter how closely you magnify the view on them, a similar pattern of jagged edges appear right down to the very grains of sand and atoms beyond. And down at that atomic level, the coastline is always shifting around because of erosion caused by constant wind and tidal forces, which theoretically could mean that your measurement of the coast could become infinitely long and is thus undefined without an exact, satisfying answer. In these kinds of environments, the best any of us can really ever do is simply estimate the length of the coast. As Mandelbrot asserted in his paper when he wrote, "Coastline length turns out to be an elusive notion that slips between the fingers of those who want to grasp it. Therefore, any measurement of any coastline you ever see going forward is not exact, and will always be an estimation based on the biases and methods used by the person or organization that did the measuring. Always take them with a grain of salt and skepticism." Now, you can learn even more about the coastline paradox and the beautiful world of geometry through today's sponsor, Brilliant, which heavily inspired this whole video you just watched. Before making this video, I had a basic understanding of geometry from classes I took more than a decade ago in high school, but anything much more complicated was just going right over my head. I've always struggled with learning math and science, and I don't know what I don't know, which makes asking the right questions online to Professor Google really tough. But then I went through Brilliant's course on beautiful geometry, which took me through from the very basics I understood, tested my understanding along the way, and explained to me the correct answers in detail anytime I got something wrong. One of the most difficult parts for me about learning anything new is simply knowing what the right questions are to ask. But Brilliant removes that barrier for you with curated and guided courses that are designed to steadily level up your knowledge. You can take the course I did on Brilliant Geometry that includes this daily challenge on the coastline paradox, or you can choose to take one of Brilliant's many other courses, from beginner subjects like Introduction to Algebra and Introduction to Probability, to more advanced topics like Calculus in a Nutshell and Computer Science Fundamentals. And best of all, you can sign up for Brilliant's completely free trial when using the link down in the description below at brilliant.org/RealLifeLore, or by clicking the button that's here on your screen right now, which will take you to the same link. And if you find it useful, which I'm sure you will, the first 200 people to use my link can continue with 20% off of the annual premium subscription for a great year of fun STEM learning through 2023. It's a great way to help support this channel while you're at it, and it works as a great gift for the holidays as well. And as always, thank you so much for watching.